Hello everyone, welcome back to Code Enzyme, and in this video we will discuss the problem array operations from Status 127. So before starting this video, I would like you to hit that like and subscribe button and kindly watch this video till end to actually understand the whole problem. Now, okay, so let's first read the problem statement. An H index array is defined to be the maximum integer H, such that there are at least H elements in the array which are greater than or equal to H. So, for example, let's first actually understand what this line means. So, if you have an array, let's say 1, 2, 3, 4, 5. Okay. So, is this array one index? Like, is this array can h equals to 1? So, if you read, an h index is the array that is the maximum integer h such that there are at least h integers elements in the array which are greater than or equal to h. So if you check for 1, there are 1, 2, 3, 4, 5. So 5 elements which are greater than or equal to 1. So h can be 1. Okay. So in this case, h can be 1. Can h be equal to 2? So 2, 3, 4, 5. So there are more than 2 integers which are greater than or equal to 2. So 2 is also possible. H equal to 3. There are 3, 4, 5. So 3 is also possible. H equal to 4. Now there are only 2 integers in this array which are greater than or equal to 4. So h can't be 4. Can h be equals to 5? There are only one integer 5 that is greater than or equal to 5, so h can't be 5. So hence for this array the h index will be equal to 3. Okay, so I hope the statement is quite clear now. Now let's read further. You are given an integer array. You are given an integer array a and a positive integer k. You can do the following operations as many times as possible, possibly none. Pick two indices I and j such that ai is divisible by k and aj is not divisible by k, and then we divide ai by k and multiply ai by k. Okay. Okay. So yeah, we divide ai by k and then we multiply aj by k such that aj was not divisible. So find the maximum possible h index of array that can be attained by performing the above operation as many times as you like. And n goes till 3 into 10 to the power 5, so it is looking for an n log n type solution. So I will even write it for you. Wait a second, let me erase everything. Okay, so I mean n is going till in the order of 3 into 10 to the power 5. So it is clearly asking for a big O of n type solution or a big O of n log n time solution. Okay. Now if you read the statement and like if you saw the working how we actually find the h index array, you can clearly see that I checked for h equals to, can h be equals to 1, can h be equals to 2, and then we go on till h equals to x, and then we see h equals to x plus, can h be equals to x plus 1, and then we go on like this. So if this is true, then x minus 1, for x minus 1 it will also be true, right? So for this it gave a true, then we had a true, and then at some point for x plus 1, if the function gave a false, like h index cannot be x plus 1, so all the further down values will also give false. So we had a array of true true true, and then we suddenly got a false, and then we are always getting a false. And let's say if we have a function which is like this, so for some increasing values it is giving true true true, and then at some point it started giving false, then this function is called a predicate function. Okay. I mean, I think most of you will be familiar if you are in Div 2, but for those who don't know about binary search on answer, I just want to introduce you this, that if you can, if x is an answer, and like it can also be like false 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 false, and then true, like, but there's basically there is only one point at one point at which the change occurs, and we want to find that point. Okay, so in such kind of problems we use binary search on answer. Okay. So what is binary search? Like, let's say now this is theory for binary search on answer. So if you are familiar with it, you can skip ahead. I know that will make the video longer, but just for those who are new to binary search, let's say you have a series of true, like it was giving true, and then suddenly it gave you a false, 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 and for other things it is false, right? Um, so you have such a sample space, okay? So like you can check for if is uh, can one be the H index? It gave you a true. Then can this be H index? It gave you a true, and you need to find the maximum value for which it is giving you a true, right? So what you can do is you can let's say your low pointer points to here, and high pointer points to here, and let's say initially the mid value is this. If this is the mid value, and you query for this mid value, can this be the answer? It says true. So what you will do is you will move your low pointer to mid plus 1 and initialize this is the answer. Then you query for the value. This is let's say this is the mid 2, and you saw that it was false. So what you will do is you can uh, shift this to this place. Okay, the high pointer, and then you will keep doing this till you reach here, and this will happen in login time, and like that you will be able to find the answer. And there is actually a tagline for such kind of problems. Whenever you have to like maximize the minimum or minimize the maximum, such kind of problems are generally solved using binary search on answer. So this is an advanced technique. I mean, I won't say too advanced. It is generally asked in coding interviews, but yeah, for those who are new, you might find it difficult to implement this. But yeah, this is a technique called binary search on answer. So if you are not familiar with it, you can feel free to actually pause this video and learn about this and then come back. Okay, but I don't think it is necessary. You will be able to understand the solution pretty easily. Uh, okay, so let's forget about binary search for now and let's try to focus on the problem. Um, if you see, like, what does the problem ask? You are given an integer array A, and okay, and we want to, if AI is divisible by k, we can actually divide it and then multiply it with something, right? So let's say we have some array A1, A2 till an, right? And if A2 is divisible by k, I can divide this by make it A2 by k, and then I choose some AX which was not divisible by k, and actually increase it. Okay, increase it to what? Increase it to something which is greater than equals to the H index that I want. Okay, so the question, I mean, like from this diagram, that how we are finding the H index, and from the statement that we have to maximize the minimum. Like if you see the question says find the maximum value possible of H index, like that. So from this I know that this problem, sorry about the noise if you could hear it. Now from this I really know that this problem has to be solved using binary search. Uh, I know it is not a good idea to actually force an algorithm on a problem, but right now I was really sure that okay, we have to apply binary search on this problem. And since this is a binary search problem, I will have to query like uh, if we have a mid value, can this be my answer or not? I will need to make a function which will take this mid parameter, and it will work on this array, and it will tell me that give me either a true uh, okay, sorry about that. It will either give me a true or a false value. True means that okay, this mid could be your answer, and false means that this h cannot be my answer. And this function I will run login times, and after running it login times, I will arrive at my answer. Okay, so what will be the lower bound? So lower bound will obviously be equals to 1, and the higher bound, like how many, what is the maximum h index? It can be n, right? Uh, so I have to run on this n space the binary search on answer. Now, how do we code the check function? Like the function that will return the uh, true or false, right? Can this mid be my answer or not? So basically, uh, okay, let's try to first understand one of the test cases, and from that, let's see. Okay, so we have 3, 5, 4, 1, 0, 10. Okay, so we have 3, 5, 4, 1. Did we have a 0? 1 and 10. Okay, so we have this, and clearly, I mean, from this output, I know that the answer will be 4. Okay, um, okay, and what was the k value for this? K value is 2. Okay, so okay, I mean there is only one value, that is 4, which is this a good test case? Like for 4, 1, 2, 3. Okay, but right now I need at least one more value which is greater than equals to 4. If I divide it, I mean there is no sense in dividing it by 2 and multiplying other by something else by uh, 2, right? I mean it is possible, but there is no sense in doing that. Why is the answer for this case equals to 4? They chose I equals to 5 and j equals to 1 and divided 5 by 2. So 1, 2, 3, 4. Okay, okay, I got it. Okay. So basically we could divide this by 2. So we made it equal to 5, and then I think they made this equals to 6. So now we have four numbers which are greater than equals to 4, which are greater than equals to 4, and that is why for check of 4 it will return true. Okay. Similarly, I think we can do it for 3. So if I rewrite everything again. So let's say 3, 5, 4, 1, 10, 3, 5, 4, 1, and 10. Okay. So what do we really need? Like uh, we just want to find the minimum value. Like how many times? Let's make a requirement array. Okay. Like how many times, what power of k should I multiply to this value to make it just greater than or equal to k, the mid value, that is whatever the mid that I will pass in here. So let's say if my mid equals to 4 for this test case, like for 4, I will also need the base, right? Uh, let's actually have two arrays. So let's say my base array. So base is 3, 5. In this case, the base is 1. The base is 1, and in here also the base is 5. Base is basically any number can be written as base into k to the power something, right? And let's also have the power value. So what power of k does this array does this value have? So it has 0, this also has 0, this has 2, this has 0, this has 1, right? So like that. So these are the power of k that were present in this, and this is the base value that I will get when I keep dividing the values by something, by this k, right? And what is the requirement? What does this requirement array will store? It will store by what power should I multiply this such that I will be able to make this value just greater than equal to the mid value, or just greater than equal to 4 in this case. Okay, so clearly I have to multiply once. In here I don't really need to. If I want to multiply the base, I need to have at least 2. Okay, and in here I need to have at least 2. Yeah, and for this 5, uh, I don't really need to multiply it, so let's say 0. And now okay, and now I will ask you something, like which value should I try to make greater than equal to 4 first? The bigger values, right? Like the larger the value, it is I need the smaller powers that I need, right? Like I know the total that I have is 3. I can maximum contribute a power of 3 to some elements, right? So I should make the large bases first, large bases. Uh, so I should multiply the powers with the large bases first, right? So what I can do is, okay. So first thing that I will choose is the large bases, that is five, these fives. Okay. So for this five, let's say this five. Now for this five, I know that it doesn't really need. So let's say plus plus. My answer is one. So this will contribute a plus one to the answer. So okay, one value is this. Then I will go to the next bigger, which is this five. Now this five has a power of one, and it doesn't really need anything, right? So this will, uh, what does it tell me? So I should try to reduce this power, right? I can easily divide this. It didn't really need it. So I should be able to divide this power, right? So what I will do is, okay, I will divide it by 1, because it required only 0 and it had 1. So I will just take the difference and minimize it, right? And now when I go to this index, I still had two powers with me, because in here I reduced one, right? So I still have two power. Okay, let's say I still have three powers with me, because in here I didn't need to actually increase the power, right? So I still have a power of 2 with me. And now when the base was 3, like now I'm trying to go for the next best, which is 3. And 3, I needed a power of 1 and I had a power of 0. But in this case, and I still have the three powers. Okay, so what I will do is I will increase this by 1, and now I'm only left with two powers. Okay, so this gave me a plus 1, this gave me a plus 1, and then I reached one of these two values. Let's say I go to this value first, because it had more power with it. So this value, it already has a power of 2. It needs a power of 2, so doesn't really make sense to divide or give it more power. Then I go to, so this will also give me a plus 1. And now this value, when I go to this value, it requires a power of 2, but and it has a power of 0. But uh, no, wait a second. Yeah, it required a power of 2, so I have to give this these two powers to this guy, right? Yeah. I think I think I confused you. So let's actually, I will just sort this. I think it will become more clear in the code. So first of all, like, let me just copy this thing. I think it is already copied. Okay. So the first thing we have is n and k values, right? So int n and k, c in n and k. And what I really need is the array. So let's say vector int a of n, and for I, c in a of I. But the problem is I don't really need the array. I need those values, that is the base and the exponent that is present in this. So what I will do is I will make it pair indent. Okay, and let's say int x, c in x. And first of all, I want to find the base and the power. So let's say int base is equals to x, and the power is initially 0. And while base mod k equal to 0, and also my k should be greater than 1, otherwise this will go in an infinite loop. So base is equal to base upon k, and power plus plus, right? And I will say a of I is equals to base comma power. And also I want to find the total number of k's that I have. So let's say int total is equals to 0, and total plus equals to the power. Okay, so why I'm doing this, it will become more clear in the further when we do the binary search. So the binary search template that we will use is, I mean, I do have my binary search template. You can, and the lower bound will be 1 and the upper bound will be n. That is what we discussed. And this will be opposite, because I mean, there are two kinds of binary search, right? you can try to maximize the answer and you can try to minimize this answer. Since we are trying to maximize it, whenever this check function will return true, I have to move my lower pointer to the minimum mid plus one. That is why, since we are trying to maximize it, I have to switch this up. So this is my binary search template, and now I have to code the check function, right? This will return the true or false. Now I need to find out let if this mid value is possible or not. Now to do that, I need to count the number of h values that I can get. Count the number of values that I can make. So obviously I need to sort this, reverse sort it actually. Why? Because I want to do it for the bigger bases with already bigger powers greater than equal to mid as soon as possible, right? So first I can do is sort a dot begin comma a dot end and reverse a dot begin comma a dot end. So this will just reverse them. Okay. I hope you get the idea. If you have any doubts if you have any doubts, you can tell me in the comment section and I will reply to them. But okay. Now once this is done, like how do we actually, like, I want to find out if, the minimum number of k's that I should contribute here to an a of I. I mean, there will be a loop from 0 to n, right? Uh, there will be a loop from 0 to n, and at every step I need to, first will be the count, like how many numbers which are greater than equal to mid now, uh, how many k's that I am left, which is equals to total initially, and what will we need, like, okay, let's actually find out. Int requirement, the requirement that we have is initially 0, and int current, let's say in temporary variable, which is equals to ai dot first, and while temp is less than mid, requirement plus plus, and temp star equals to k. So this is basically I'm finding out the minimum power that is required to make it just greater than equal to mid, right? And if this required value, the required value that we get, this minimum power, is less than equals to left, that the number of k's, the powers that I already have, then I should just give it this, right? But there is a catch. Like, should I always give this this the power? Because I generally don't, like, okay, let's say we have the required value. I mean, let's take it from the example. Um, let's say I was here at this value. It had a requirement of 0 actually, and it had a power of 1. So okay, I will skip it because the requirement is already 0, so I don't really need it. But I mean, the requirement is less than equals to left, and there should be something more, right? Um, for this case, 3. I had powers 3. I mean, the amount of k that was left is 3, and now the requirement is 1. And okay, so one case is simply if the power, if the requirement is equals to 1 and the power that it has equals 0, then I should definitely try to do this, right? Not power, I should say the a of I dot second. Then I should say requirement, sorry, left minus equals to requirement, right? And the current plus plus, the current, sorry, count plus plus. So this L number will become greater than equals to the mid value, and the requirement decreases by 1, right? And why do we only have it when the requirement is 1? Why not like greater than equals to 2 or something like that? You will this will become more clear when we do something. Let's actually try some other examples. Let's say we have 2 and 3, 9 and 1. So for this case, I can take things from here. Like I had a power of this will become 1 comma 1, and the powers will become 3, right? 2, right? So I can distribute them to 2 and 2 and make them equal to 3 and 3, so the answer will become 2 for this case. Okay, so yeah, what else? I mean, there should be more cases. Like one case is this definitely. What is the other case? The other case can be when the requirement is more than one, and okay, let's say when the requirement is more than one, but this requirement is less than equals to a of I dot second, right? If this is the case, like the a of I dot second, which has the power, and this requirement was actually less than equals to this, then I should simply decrease the left count. I mean, this number is much more greater, like this one. In this case, 5 comma 10 comma 5, the requirement is less, but this power is more. You realize what I'm telling you, right? So I have to give it I have to give it this value and increase my count, right? I hope you are able to realize. What if we had something like 3 here and 1 here? So I had to I had to reduce this answer by 1, um, right? My powers will reduce by 1 because I'm giving this power to this, right? So that is why I'm doing this step, and I think that is pretty much it. If the count is greater than equals to mid value, then I will return a true. Otherwise, I will return false. So that pretty much completes the code. If I run this, then I'm getting 4 to 2, which is the correct answer. And yeah, that is pretty much the code. If I submit it, let's see what do we get. Yeah, we got a correct answer, and so that is pretty much the solution. If you have any doubts, you can comment it. I know I'm not very good at explaining the stuffs, but I hope you were able to understand it. And if you did, if you watched it here, I really can't thank you enough. Kindly subscribe to the channel, and I will see you guys next time. Thank you.